This is RD Sharma Solution Class 12, Chapter 5. Algebra of Matrices. Exercise is 5.1. The first question is, if a matrix has 8 elements, what are the possible orders it can have? What if it has 5 elements? First of all, for a matrix, how many elements will be there? Matrix is just a table. It's a row and column arrangement of elements, numbers, values. For example, if we have 8 elements, we can distribute or arrange them like this. So this is one of the formation. So there are 2 rows and 4 columns. 2 rows and 4 columns. So how many orders or dimensions are possible? If n by m is the order, n is the row, m is the column. So n into m are the number of elements that this matrix can contain, right? For 8, what are the possible multiplication? That is 2 values multiplied. How many times do you get it? Because 1 into 8 is 8. 8 into 1 is also 8. What all combinations can be there? 2 into 4, this is also 8. And 4 into 8, this is also 8. So, do we have any n into m combination other than this which can give you 8? No. So this is the order, this is the dimension. How about 5? First of all, 5 is an odd number. It's an odd number, okay? So now 2 values multiplied, how can we get an odd number? No. So what do we do? 5. So if you want to put or arrange them, so it can be only a row matrix or a column matrix. That is 5 into 1 and 1 into 5 are just the combination. So how are we going to get 5? 5 multiplied by 1 and 1 multiplied by 5. So both ways you get 5. So 5 into 1, 1, 2 into 5. 2 possible orders of the matrix. Orders, dimension, n cross m, row cross column. This is basically row cross C, column. If A is this, B is this. So A22 plus B21, and then we have to add an A11, B11 plus A22 into B22. Okay. So what do we do here? First, this Aij, I is referring to row number, J refers to the column number. So let us number it. 2, 3, negative 5. We have 1, 4 and 9. 0, 7, minus 2. Then we have this B, 2, negative 1, negative 3, 4, 1 and 2. So whenever we represent Aij, I is the row number, J is the column number, right? So let me just number it. This is first row, first column, 1, 1. So there are 3 rows. So 1, let us name it as 1 and 2 and 3, number it. And 1, 2, 3 are the columns. There are also 1, 2, 3 and 1, 2. Now the intersection 1 and 1. So just write A11. Subscript should be 1, 1. A12, A13. This also A21, A22, A23. Here we have A31. Third row, first column. A32 and A33. Similarly here I am writing A, but I'll change it to B. So A11, A12, A21, A22, A31, A32. Okay. Now just come here. A22. Which one is this number? 4. First one we are doing 4 plus B21. So I'm just changing it to B because the question is giving B. I'm just replacing it by B. So coming to B21. What is B21? Negative 3. So 4 plus minus 3 is 1. 4 minus 3 is 1. Now coming to the second one. A11, B11. So A11 it is 2. What is B11? It's again 2 multiplied by 2 plus what is A22? We just took it 4 and B22. B22 is also 4. What do you get? 2 2s are 4 and 4 4s are 16. 16 plus 4 is 20. This will be the final result. Let A be the matrix of order 3 cross 4. Let R1 denotes the first row of A and C2 denotes its second column. Then determine the orders of matrices R1 and C2. So here it is talking about a row matrix and column matrix. Please remember, row matrix will only have row. A column matrix will only have one column. Row matrix will have only one row. So this is 3 rows and 4 columns. So this is R1 because there are 3 rows, R1, R2 and R3. Because there are 3 rows. How about columns? C1, C2, C3 and C4. 4 columns are there. So R1 is the first row. C2 is the second column. So the numbers are not given, the values are not given. But we just have to find out the order or the dimension of a row. A dimension of row will always be 1 cross something. 1 row means 1 will be the dimension. Column, it will be n cross n, because column means it has 1 column. So if I write R1, there will be how many elements? 4 elements. I don't know the element. I'm just assuming there are 4 elements here. This is R1. Okay. This is R1, 4 elements. So this is what is the dimension? 1 row and 4 columns. So 1 cross 4. We'll just write 1, 2, 3, 4. So 1 row, 4 column. And similarly here, the column 2. Column 2, how do you write column 2? So this is the first element, second, third. So 3 elements will be there, column wise. Right? R1, R2, R3. So it will be, these are the 3 elements here. We don't know the element, but we do know the dimension. There are 3 rows, but only 1 column. So 3 cross 1 is the result. R1, 1 cross 4, C2, 3 cross 1. Construct a 2 by 3 matrix Aij A, whose Aij are given by. So what we'll do, we know in Aij, I represents the row number, J represents the column number. So we'll take them and then we'll compute all these. Right? The 2 by 3 matrix is there. So 2 rows and 3 columns. So I'll give you all of these one by one. Okay. So the first one I'm making. All these 4 options we are going to do it here only. So the first one will be I into J. So it's 2 by 3 matrix. Okay. So just write it here. It's 2 rows and 3 columns. 2 rows and 3 columns. So A, first row, second row, and then we have 3 columns, 1, 2, 3. So this will be A11, this will be A12, this will be A13, this will be A21, A22 and A23. So just remember, just multiply I and J and put it in the place of A11. That is, just multiply 1 into 1 and put it here. 1 into 2, 2, 1 into 3, 3. Similarly, 2 into 1, 2, 2 into 2, 4, 2 into 3, 6. Clear? How did it come? Now coming to 2i minus j. 2i minus j will be 2 into I. I is what? The row number. So A11, I is 1, j is 1. So 2 into 1 minus j. 2 into I, that is 2 into 1, minus j, that is 2. 2 into I, that is 2 into 1, minus j, 3. Here also 2 into 2 minus 1, j. 2 into 2 minus 2. 2 into 2 minus 3. 2 minus 3. 2 to the 4 minus 3. Okay. Just compute it. 2 minus 1 is 1. Then 2 minus 2 is 0. Then 2 minus 3 is negative 1. So just write it 0. 0 and 2 minus 3 is negative 1. 4 minus 1 is 3. 4 minus 2, 2 to the 4 minus 2 is 2. 4 minus 3 is 1. So this is the final result. Okay. So this first matrix was the answer of the first one. And second one is there, which I wrote here. I plus j. So I plus j, just add these I and j. I'm just adding it. So the third part I'm doing. 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. 2 plus 1, 3. 2 plus 2, 4. And 2 plus 3 is 5. So this is the third one. Now I plus j whole square by 2. I plus j whole square by 2. So take the row and column, add them, square them and divide by 2. So 1 plus 1 whole square by 2. Here we have 1 plus 2 whole square by 2. 1 plus 3 whole square by 2. Then we have 2 plus 1 whole square by 2. 2 plus 2 whole square by 2. 2 plus 3 whole square by 2. Okay, let us compute it. This is 1 plus 1 is 2. 2 square. 2 gets cancelled, so you only get 2. 1 plus 2 is 3. 3 square is 9. 9 by 2. 3 plus 1 is 4. 4 4 is 16. And 16 divided by 2 is 8. I'm writing it here only. Again, same thing as the middle part of the first row. 9 by 8. This is also like the last part of first row, so it will be 8. 2 plus 3 is 5. 5 is 25. 25 divided by 2 is 25. So this is the final result. Okay. Now question number 5. So we have to construct a 2 by 2 matrix Aij whose elements Aij are given by. So what all we have done or what all we have already understood, will not do that. If we have similar type of part, we'll do just one of them. So I plus j whole square by 2 we have already done. You just saw it. And next one is I minus j whole square by 2. This also you will be able to do. I'm just skipping it. Now the third and fourth part, CBSE 2002. So I minus 2j or 2i plus j, they are almost similar. So we will take one of these. And the fifth and sixth part will also take one of these. So let us see here. The third and fourth are almost similar. Okay, we'll do the third one. So this is 2 by 2 matrix. So we have 2 rows and 2 columns. So 2 rows and 2 columns. This will be A11, A12. This is A21 and A22. Okay. So just put I as the value which is the row number and j as the column number. So I minus 2j. 1 minus 1 minus 2 into 1. First will be 1 minus 2 into 1 whole square and divided by 2. Next one will be A12. So I is 1, j is 2. So 1 minus 2 into 2 whole square by 2. A21. 1 minus 2 into 1 whole square. 2 minus 2 into 1 by 2. This will be 2 minus 2 into 2 whole square by 2. This is I is 2, j is 2. Just square it and divide it by 2. Okay. So this is 1 minus 2, that is going to be negative 1. Negative 1 whole square is 1. So 1 by 2. The result will be 1 by 2. 1 minus 2 to the 4. So 1 minus 4 is negative 3. Negative 3 whole square is 9. 9 by 2. 2 minus 2, that is going to be 0. Let's put 0. 2 minus 4 is negative 2. Negative 2 whole square is 4. 4 divided by 2 is 2. So you get 2 here. This is the whole answer, 2 by 2 matrix. I hope you'll be able to do 2i plus j whole square by 2. They are almost similar, okay? The next one, this fifth and sixth part. Because they have the modulus. All other things remains the same. Only the modulus is somewhat different. We'll do this fifth one. Sixth, I hope you'll be able to do it if you learn this fifth one. So 2i minus 3j divided by 2. So modulus means whatever comes inside, it will always be giving you the positive. So let me make it again. We have A11, A1. This is first row, second column, first row, second column, A2 by 2. That is 2 by 2 matrix is there. So A11, A12, A21, A22. Right? So the first one we are taking 2i minus 3j. So 2 into, this is I is 1, j is 1. Similarly for others also will do the same thing. If you understand I and j, how to put this, these questions are quite easily solvable. So 2 into 1 minus 3 into 1. I and j both are 1 here. Divided by 2, and we have to put a modulus also. Similarly here, modulus 2 into 1 minus 3 into 2. 2 divided by 2. Okay. 2 into 2 minus 3 into 1 divided by 2. Here also 2 into 2 minus 3 into 2 divided by 2. All these are in modulus. So just compute. If it is negative, just place it as positive. So negative 1 it will come, 1 by 2. 2 minus 6, it will be negative 2 minus 6 is negative 4. Negative 4 divided by 2 is negative 2 because it is modulus, so we will just write 2. 4 minus 3, this is 1, 1 by 2. 4 minus 6 is going to be minus 2, minus minus cancels, you get, this is the result. Okay. So this also you will be able to do, right? Construct a 3 by 4 matrix A equals A subscript ij, whose elements aij is given by. So there are certain parts, and this is a NCERT question. How are we going to do this? Let us start with the first part. I plus j is the row and column addition, the row and column number. So the best way is to first make a dummy matrix because it is 3 by 4 matrix. So how do we write? This is A, and these are 3 rows and 4 columns. So 1, 2, 3, 4, 1, 2, 3. Row are 3 and columns are 4. So A11, A12, A13, A4, A21, A22, A1, A23, and A24, A31, A32, and A33, and A34. Now what is I plus j? I plus j is whatever is the subscript, just add it. That is I and j. So just adding, this is 2 plus 1, 3, this is 1 plus 3, 4, 1 plus 4 is 5. Just add this, 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, and 2 plus 4, this is 6. 3, 1, 4, 3, 2, 5, 3, 3, 6, 3, 4, 7. Okay. Now I minus j. I minus j, just take this I and j and subtract it. That is, whatever is in the subscript, just subtract it. I am doing it here. 1 minus 1, 0, 1 minus 2, negative 1, and 1 minus 3, negative 2. 1 minus 4, that is negative 3. 1 minus, this 2 minus 1 is 1, 2 minus 2 is 0. Now it will repeat. That is, whatever is coming after 0 in the first row, it is going to repeat. 0, negative 1, negative 2. Similarly, 3 minus 1 is 2, 3 minus 2 is 1, 3 minus 3 is 0, and 3 minus 4 is negative 1. Okay. Now 2i. So just take the first one of the subscript and multiply it by 2 and write it here. That is the row number. And see, in the first column, first row, all the values are same. 1 into 2, 1 into 2. So you have to multiply 2 with 1, 1, 1, 1, 1. So 2, 2, 2, 2 will come. Multiply 2 with 1, 1, 1, 1. So 2, 2, 2, 2, 2 will come. Here now you have 2 as the I value. So multiplied by 2. 2 into 2 is, this is going to be 4. 4, 4, 4, 4. Then we have, this is 3 into 2. So 6, 6, 6, 6. This will come. So 2i is done. Now j. J is the subscript I and j. Only take the second one and just write it in the matrix. I'm writing it here. Just take this. Take the second one. So just write the column number. Nothing else. So 1, 2, 3, 4. Next also you have 1, 2, 3, 4. Same thing. You just have to write j. So 1, 2, 3, 4. Here also 1, 2, 3, 4. 1, 2, 3, 4. Okay. So I told you all of these, and this is the I minus j one, which we already discussed. And then we have the 2i. This also we have done. And then we have j, which is 1, 2, 3, 4 in all the rows, 3 rows. Now coming to the this fifth one, aij. We have already done this in the fifth question, I guess, but we'll try to do it here also, because you just have to take I and j, put it here, and whatever is coming after the computation, take the modulus of it. Modulus is, okay, just make this, we have 3 rows and 4 columns. So this is 3 cross 4. Now this is A11, A12, A13, A14. This is going to be A21, A22, A23, and A24. Here A31, A32, A33, A34. Okay. So minus 3i plus j. And we have to take the modulus also. This is 1 and 1. So minus 3 into 1 plus 1. I is 1, j is 1. Minus 3 into 1 plus 1. And you have to take the modulus of it and divide it by 2. I hope you got the idea. Now again 1 and 2. I is 1, j is 2. So minus 3 into 1 plus 2. And take the modulus. Similarly here 1 and 3. Similarly here 1 and 4. So by 2 is already there. So 1, I just write a 1 as I. So now minus 3 into 1 plus j, that is 3. It is 3. Okay, I'll just change it. It is 3. Fourth one is minus 3 into 1 plus 4. So I'm just going to tell you the first row, second and third. I hope you will be able to do it. So this will be, I'm just saying second and third row, please do it by yourself. So this will be minus 3 plus minus 3 plus 1, so minus 2, and mod is minus 2, mod is 2, 2 by 2 is 1. So minus 3 in here, minus 3, and 2 minus 3 is 1, and negative 1 is plus 1, 1 by 2. The third one is 0, minus 3 plus 3. It is written 2, I'm just changing it, okay? I'll just change it in a bit. Last one is minus 3 into 4 plus 4, 4 minus 3 is 1, 1 by 2. So first row is 1, 1 by 2, 0 and half. And similarly, we will be able to do the second row and third row. The answer is also in front of you, but how to do it, I just explained it to you. So main thing is take the subscript I and j, and whatever computation is done, you have to take the modulus. So coming to the next one, this is the solution also. Let me just clean it so that you can just have a look. What is going to be the final answer, how to compute it. Construct a 4 by 3 matrix A equals Aij whose elements Aij is given by. Same thing we have to do, just take I and j subscript and put it here in the expression, and whatever the value will come, put it at the place of that subscript, that is particular value of the matrix. So let me just make the 4 by 3 matrix first. It will become more easier to solve if we just make this matrix up front. 4 rows and 3 columns. 1, 2, 3, 4. So we have A11, A12, A13, A21, A22, A23, A31, A32, A33, and A41, A42, A43. So you know this first and second questions are almost same. I'm just taking the first one. The second part I leave it for you. The third part also I will do. So just use this formula 2i plus I by j. So 2 into 1 plus I by j. That is 1 by 1. Second one is 2 into 1 plus I by j, 1 by 2. This is 2 into I is 1 plus 1 by 3. Now you see a pattern. 2 into 1, 2 into 1, 2 into 1 is already there. 1 by 1, 1 by 2, 1 by 3. Similarly, there will be a pattern here also. 2 into 2, because it is 2i. 2 into 2, and this is I by j. So 1 by 1, 1 by 2, 1 by 3. This will be I by j. So 2 by 1 it will be. It's not 1 by 2. It's 2 by 1. And 2 by 1, 2 by 2, 2 by 3 it will come. And that will be 2 by 2, 2 by 2, 2 by 2 everywhere. I hope you got the idea. There is a proper pattern it is going to follow. So this is 2 by 2. Just write 2 by 2 everywhere in the second row. And then we have this 2 by 1, 2 by 2. And then we'll have 2 by 3. So 2 into 2, 2 into 2 plus 2 by 1, 2 by 2 and 2 by 3. So in the same way, we are going to write the other one also. So 2 into 3 it will be. So just write 2 into 3, 2 into 4. and this is 1 by 1, 2 by 1, so the 3 by 1, it will be 4 by 1. So 2 by 3, 2 by 4 here, 2 by 3 here, 2 by 4 here, plus. So it was 3 by 1, it will be 3 by 2, and then we have, it will be 3 by 1, 3 by 2, and 3 by 3. Here we have 4 by 1, 4 by 2, and 4 by 3. So 4 by 1, 4 by 2, and 4 by 3. So there is a proper pattern we followed, and this you have to do for the second question also, same way. So what will be the first one? See, 2 plus 1, this is going to 3. 2 plus 1 by 2. Let us do 2 plus 1 by 2. That is 2 into 2, 4. 1 is 1, and by 2. That is going to be 5 by 2. The third one, 2 plus 1 by 3. So this will be 2 3 is 6 plus 1 by 3. It will be 7 by 3. Next one, 2 into 2 is 4. 4 plus 2 is 6. So 4 plus 2 is 6. Next one, 2 into 2 plus 2 by 2 is 1. So 2 into 2, 4 plus 1 is 5. Then 2 into 2 is 4. 4 plus 2 by 3. So let us do 4 plus 2 by 3. 4 is a 12 plus 2 by 3. It is 14 by 3. This is 14 by 3. Now coming to the third row. 3 to the 6. 6 plus 3 is going to be 9. 2 into 3 is 6. 6 plus 3 by 2. Right? So 6 plus 3 by 2. Let us do 6. 6 into 2 is 12. 12 plus 3 by 2. That is going to be 15 by 2. About this, 2 3 is 6. 6 plus 3 by 3 is 1. 6 plus 1 is 7. Let's write 7 here. 4 to the 8. 8 plus 4 is 12. 4 to the 8. 8 plus this 4 by 2 is 2. That is going to be 10. 4 to the 8. 8 plus 4 by 3. So 8 is 24. Plus 4 by 3. 28 by 3. Okay. So I'll just leave this I minus j by I plus j for you because it takes certain time. But you know the idea how you're going to make. Third one, I'm doing it here. Just write the first one. That is I. You just have to take the I and put it here. So AI, you are going to take the row number 111. Then we have 222. Then 333 and 444. Okay. So this is the second one which I am going to show you just now how we are going to do it, so that you can do it by yourself also. This all you have to compute one by one, means 12 values. 4 is 12 values you have to compute with respect to I and j. I is corresponding to the row number and j is column. So now the third one also we just did. Okay. This is with respect to the equal matrix. So equal matrix means whenever we have two matrices as equal, then just equate the corresponding position values. So we have A, B and XY here, and we have to find out XY and AB. So we will make the linear equations here. How are we going to make the linear equation? First, please understand the corresponding elements of two equal matrices are always equal. So 3x plus 4y, and just see which position 3x plus 4y is corresponding to in the next matrix. So 3x plus 4y is equivalent to 2. X minus 2y is equal to 4. Just write x minus 2y. What you have to do, just multiply this by 2, the second equation. It's going to be 2x minus 4y equals 4 to the 8. Now take this here, 3x plus 4y equals 2. Add this equation, both equations, negative positive cancels. 3x plus 2x is 5x, 8 plus 2 is 10, x is 10 by 5, that is going to be 2. Okay. Now put this x in any of these two equations. So I am putting it in the second one. So 2 minus 2 into y equals 4. 2y becomes 2 minus 4. Y equals minus 2 by 2, that is going to be negative 1. So y is negative 1 here. And this gave us the value of x and y. Coming to a and b now. So a plus b equals now, which one is there? 5. And 2a minus b is equal to negative 5. 2a, b is negative 5. Now just add these. we get a plus 2a, that is 3a equals 0. A is equal to 0 here. Now b is, just put a as 0 is some in any of the equation, b is going to be also 5. Similarly, in this also you just have to equate the values. So we have to find out x, y, and a and b in the similar way. We'll try to solve this one, 2x minus 3y, equate it with 1. Now this is 2 by 3 matrix. First of all, the matrix have to be at the same order in order to be equal. 2x minus 3y equals 1 and x plus 4y is equal to 6. So this is x plus 4y. Just I multiply this equation by 2. I multiply whole equation by 2 and I'm writing it here. So 2x plus 4 to the 8y equals 6 to the 12. So x plus 4y equals 6 multiplied by 2. Now just add these and subtract basically, so that you get cancel 2x and 2x. So minus 3y minus 8y is minus 11y. 1 minus 11, 12 is negative 11. So negative 11y equals negative 11. So this gets cancelled. Y equals 1. So when you have y equals 1, put it here. Put it here in any of the equation. 2x minus 3 into 1 equals 1. 2x equals 1 plus 3 is 4. X equals 4 by 2, that is 2. Now coming to the values of a and b. A minus b, just equated. A minus b is equal to minus 2. 3a plus 4b is equal to 29. Now since negative b is there, just multiply this whole equation. A minus b equals minus 2 by 4. So multiply it by 4. So multiplying it by 4, 4a, 4b, this is going to be 4 to the 8. Okay, let's add this to equation. 3a plus 4a is 7a. 29 minus 8 is 21. A is 7 3 is 21. So it becomes 3. A is 3. Now put it any of the equation. A minus b is negative 2, quite easy. So a is 3. 3 minus b is negative 2. So b is 3 plus 2, that is 5. So b is going to be 5. So you can recheck also. If you want, you can just recheck whether this equation is coming or not, whether these values are satisfying this equation or not. I'm just rechecking it. So a and b we got, and we already got it minus 2. 3 minus 5 is minus 2. This is how you have to do it. You can just have a look. Now same way we are going to do it here. We'll just equate the corresponding values and try to find out the actual value. So just if you want to do it in your textbook or wherever you want, the answer book, just write like this. I'll just do it quickly here. 2a plus b equals 4 here, and a minus 2b. So just take a and b equation first. A minus 2b equals negative 3. So multiply the first equation by 2, write it here. So it will be 4a plus 2b equals 4 to the 8. Now just add it, cancel these. 4a is 5a, 8 minus 3 is 5, a will be equal to 1. So a is equal to 1. Now just put it in this any of the equation, you will get 2 to 1 plus b equals 4, b equals 4 minus 2, that is going to be 2. A and b. Now coming to c and d. Previous questions it was x and y. Here it is. This c and d. So 5c minus d equals 11, and then we have 4c plus 3d equals 24. So now multiply this first equation by 3. So we just want to cancel this dd. So I'm multiplying the first equation by 3. 15c minus 3d equals 33. Just add these two. 15 plus 4 is 19. 24 plus 33 is 57. 19 into 3 is 57. So what do you get? C equals 3. 57 by 19 is nothing but 3. Now put this in any of the equation, that is, so I am writing it in 5 into 3 minus d equals 11. 15. 15 minus d is 11. D will be equal to 4. These are all the values. Okay. For what value of x and y are the following matrices equal? So let us see one by one. What does it mean when we say matrices are equal? The corresponding values or the positions values are equal. So 2x plus 1 equals x plus 3. What do we get? 2x minus x is equal to 3 minus 1, that is x is equal to 2. Now coming to y, we will get two equations here. One is 2y equals y square plus 2, that is 2y equals y square plus 2. I am just making it as a quadratic equation. So y square minus 2y plus 2 equals 0. Y square. So I'll just stop here because I would like to tell you that there are two values which will come for y, and that will come from the second equation. But there is a catch here in this. I'll just show you what is the catch. Why these matrices cannot be for any value of y, it can be cannot be equal. So y square minus 5y equals minus 6. That means y square minus 5y plus 6 equals 0. So y square minus 2y minus 3y plus 6 equals 0. We have y minus 2 and negative 3, y minus 2 equals 0. From here you get y equals 2 and y equals 3. Now coming back here. So we'll use the Sridharacharya formula and I'll tell you what is the problem here. Y equals, this is minus b plus minus under root b square minus 4ac by 2a. This is how we get the two roots of this equation, which will make this equation 0. So I am equating this equation with ax square plus bx plus c. What is a here? 1. B is negative 2. C is 2. Let me write it here. A is 1. B is negative 2. And C is 2. Okay. Now put it here. Minus b is, minus minus is 2. So 2 plus minus under root b square. So negative 2 whole square is 4 minus 4 into AC. 4 into 1 into 2. 4 into 1 into 2. Okay. Oh, it's a mistake. 4 into 2, that is 4 to the 8. So 2 plus minus under root. This is 4 minus, it is not 4, 32. It's just 4 into 2, 8. So 4 minus 8, there is a correction, okay. 4 minus 8 is under root negative 4. It is not under root minus 20, it is under root minus 4. So there will be no point in just equating because y will not be a complex value. Find x and y and z so that a equals b, where, see, now you are getting certain value which are equivalent and certain which are like z equals 3. And what about this next value, which is 6z equals 2y. That is already there with us. So 6 into 3 is 2y. So you get y equals this 2, 3, so 6. Y gets 9 value. Now use this y to get some other value. We have x minus 2 equals y. We already have y as a 9. So this will be x equals y plus 2. That is going to be 9 plus 2, 11. So this is y plus 2 and y is already 9. So 9 plus 2 is 11. So this is all the three values. Here also we'll do the same thing. X, y, z, w. So since all the corresponding elements of a matrix are equal, so we'll take the aij of one matrix, equate it with the aij of the second matrix. So x is already 3 here. Just put x equals 3. Then we have the second one, which is 2x plus z equals 4. 2x plus z equals 4. X is 3 here. So 2 into 3 plus 2 equals 4. This is z, not this is z, okay. So z is 4. This is 6. 6 plus z equals 4. Z will be equal to negative 2. So you have z also. Now coming to z is x is 3, z equals minus 2 I am writing. Now x and z is already there. 3x minus y, this equals 2. So x is there, 3 into 3 minus y equals 2. Y equals 9 minus 2, so y will be equal to 7. So we will just write it here, y equals 7 also. Now we remain with w. So 3y minus w equals 7. We just got y, so 3 into 7 minus 7 I am taking here, w I am taking on the right hand side. 7 is 21, 21 minus 7 is 40. W equals 40. These are all the values. Next one also here. Same thing. So just equate the values. Like there are certain values which are direct. z is equal to 4, w equals 5, then we have x minus y equals -1, and then 2x minus y equals 0. So 2x minus y equals 0, we can just treat it as the linear equation. So just subtract these two. X minus 2x is -x, y gets cancelled, y minus the 1 will be plus, 1 will be minus, equals -1 minus 0 is -1, x is equal to, this gets cancelled, it is equal to 1. So x is equal to 1. Now put it here, x minus y equals -1, x as 1, y will be equal to, 1 comes here, y will be equal to 2. Okay. So y equals 2, these are all the values. Find the value of x and y if. So we'll use the direct value also and the quadratic value also. So x plus 10 is equal to 3x plus 4 because the corresponding elements of the matrix are equal. Just take these 3x minus x is equal to 10 minus 4. And there you get 2x, there you get 6. So x equals 6 by 2, that is 3. Now coming to y value. So we will get two quadratic equations here. And we will try to find out the common solution. What does it mean? That because it is quadratic, so it will give two values. So both of the equation will give you two values. So there will be 4 values. So you just have to take the common values. So first is y square plus 2y equals 3. The second one is y square minus 5y equals -4. So what is the common y value? We'll just find out. Y square plus 2y minus 3 equals 0. You can write it as y square minus 3, this is plus 3y minus y, it will be 2y, minus 3 equals 0, y you can take common, y plus 3, minus 1, y plus 3 equals 0, we have y minus 1 and y plus 3. So y minus 1 and y plus 3 is y will be equal to 1, here you get y equals minus 3. Okay, next one. Okay, y square minus 5y plus 4 equals 0. So you can write it as -4y, -y, that will be minus 5y. Y square minus 4y minus y. So y minus 4. I'll take this minus 1 common. Y minus 4 equals 0. So you get y minus 1 and y minus 4 equals 0. So this y will be equal to 1 and y will be equal to 4. Now you just have to take common. Y is -3, not on the right hand side. Y equals 4, not on the left hand side. Only y equals 1 and y equals 1 are both common. So we have to take the common value. So x equals 3 and y equals 1 are the common values. Okay, this is a 3 by 3 matrix and exactly same way you have to do which I just told you. I hope you'll be able to do it. Okay, hopefully you'll be able to do. So we have already done a question like this. X plus 3 equals 0, x will be equal to -3, z plus 4 equals 6, z will be equal to 6 minus 4, that is 2. Likewise all the values you will find. So here there is a twist. That is not x and y we have to find the x plus y. So let us see here how do we get. So if you want to write somewhere like in the classwork etc, you can write like this which I just showed you, but I'll do this 2x plus 1 equals x plus 3, 2x minus x is x, 3 minus 1 is 2. So x is 2 here. Now coming to the y scenario, because 5x equals 10 is also given. So when 5x equals 10 given, this solidifies that x is actually equal to 2. So when you write 5x equals 10, this is 2, x equals 2. Now y square plus 1 is equal to 26. That's what you have to write. So we will get two values of y. So for these two values of y, we have to find and combine this x, and then we have to find x plus y. Y square plus 1 is equal to 26. So if 1 goes there, it will be 25. So 25 can be written as, it can be -5 whole square also, it can be +5 whole square also. So y will be equal to either 5 or -5. Now I'll use this x and y, that is, we have to take both the values of y, that is x plus y. First we will take x as 2, y as 5, and similarly x plus y will take x as 2 and y as -5. So first value is giving us 5 plus 2, which is going to be 7. The second value is giving us 2 minus 5 equals -3. So this is the only point here in this particular question. It has already come in CBSE 2012. This is 7 and -3. Give an example of a row matrix which is also a common matrix. Row and column, it has to be together. a diagonal matrix which is not scalar, and a triangular matrix. Let me show you the answer first so that you just have an idea what I'm actually explaining you. Row matrix. See, row matrix will only have one row. If I write 2 and 3, this will be a row matrix, but unfortunately it has two columns. So row matrix means one row, one column matrix means one column. For example, I am writing 10. So there is one row, one column. So here is an example of 6. So you can just write one value. Now scalar is what? Scalar matrix is that you have the square matrix and all the values in the diagonal are same. For example, I'm just writing it here 2, 2, 2. This is 0, 0, 0, 0, 0, 0 like this. So this is a scalar matrix. So we just have to write a diagonal matrix which is not scalar. So just make it as 1, 2, 3 or any other value you want to write. This should not be equal. 2 to 2 should not be equal. Okay, they are not equal. This is an example of a diagonal matrix which is not scalar. A triangular matrix. Now triangular matrix are of two types. One is upper triangular matrix. The second one is lower triangular matrix. Upper triangular, the upper values are non-zeros. The lower matrix, the lower values triangular matrix are non-zeros. What does it mean? Let me show you by this. Let me write a 3 by 3 matrix, put it all 0. And then you will understand what are upper and what are lower. So why I am doing this, I'll try to show you the upper triangular matrix first. I am replacing this 0 by certain values. So I am writing 1, 4, 7, any value. You can take 8, 9 and 10. So this triangle which is the upper triangular is making this whole matrix as upper triangular matrix. Okay. The all elements which are below this main diagonal in upper triangular matrix are 0. Now let me show you the lower triangular matrix. Now I am writing certain values here. Say 2, 3, 5, 7, 8, 9 and all these aboves are 0. So this triangle are now formed here. All the elements above the main diagonal in this lower triangular matrix are 0. The sales figure of two cars dealers January 2013 showed that dealer A sold 5 deluxe, 3 premium and 4 standard cars, while dealer B sold 7 deluxe, 2 premium and 3 standard cars. Total sales over the 2-month period of January-February revealed that dealer A sold 8 deluxe, 7 premium, 6 standard. In the same 2 months, dealer B sold 10 deluxe, 5 premium, 7 standard. Write 2 by 3 matrices summarizing sales of data for January and 2-month period for each dealer. So let me show you the answer first, and then I'll try to tell you how we make the matrix. Matrix is just the arrangement of values in certain order, depicting certain value. So these are to dealer 1, dealer 2. So if I want to show or if we want to represent this value, because we are talking about 2 periods. One is January 2013 and January and February. So there are 2 periods, January 2013 and January and February. Okay. So let us take this. One is January. Please remember, I am talking about, don't worry about the timing. It's one time and second time. One time there is some sale. The second time there is another sale. So in January 2013, there is the first time period. What was the sale of our dealer 1? And what is the, how many these dealer 2 sold? So dealer 1, dealer 2, first we'll talk about dealer A with DPS, that is the deluxe, premium and standard. And for dealer 2 also, we'll do the same DPS, that is the same deluxe, premium and standard cars. Okay. So in the first row will correspond to the first dealer of that period. Okay. But we will have to do it using 2 different periods. So I am doing it for January 2013 now. So dealer 1 in January 2013, dealer 1, dealer 2, I am making a matrix now. So January 2013, deluxe, then the premium and then the standard. Okay. Right. So dealer 1, deluxe. How many? 5. Dealer 1, January 13, how many premium? 3. 4 standard. Coming to the same January period, how many by the dealer B? Right? 7 deluxe. Just write 7 below this deluxe. 7. Then 2 premium. And then 3 standard. Okay. Now coming to the second period. That is, I am talking about the 2 period month, January, February. Again same thing. Dealer 1, dealer 2. This is a deluxe, premium, standard. Same thing. for 2-month period. A sold for how many total sale over 2-month period of January, February? A sold 8 deluxe, 7 premium and 6 standard cars, 6 here. And 2-month period, same for this period, the dealer B, 10 deluxe, 5 premium and 7 standard cars. So this is the whole scenario. Okay, this is all about this discussion. Thank you so much. Take care of yourself.